For example, you have this. So this is addition symbol. This is subtract and subtraction. This is cross. Okay, multiplication. These all are the operators. Okay, or this is a square root. This is one operator, which is when this square root is operated on number 4, what we get is 2. Okay, so this is nothing but operator. We are operating on 4. When it is operated on 4, what do we get? We get number 2. Okay, same thing. Dou by dou x is the operator. Okay, when it is operated on some equation, we will get the result. In the same way, the vector operator, the vector operator, or it is the del. What it is? The symbol is the del. del. This is the symbol that it is the operator. Like this, it is simple operator. So it is defined as, this is del is equal to dou by dou x plus dou by dou y plus dou by dou z. Okay, these are the partial derivative along the axes, along the 3 axes. Okay, so here we can have this unit vector, okay, or basis vector along the x-axis, along the y-axis, along the z-axis, or you can even take it as ax, ay, and az. Okay, in the examination they may give the question in the form of ijk or ax, ay, az. That's why I'm telling you both the things. This is called as the vector operator or the del operator. So why we should use this del operator or the vector operator? Okay, so we can we can represent this vector with the equation. So we have the vector and we can represent that vector with some equation. So this is the vector which can be represented with some lengthy equation, maybe electric field, magnetic field, force, or whichever, whatever the physical quantity, that we can write in the form of equation. Okay, that equation can be operated by this operator, that is a del operator. Okay, and while solving in the derivation or while solving the equation, okay, while solving the equation, instead of writing this lengthy instead of writing this lengthy equation, simply we can write this del. Okay, del is operated on this x plus iy. So this is some equation. Okay, del is operated on this equation. Instead of writing this whole equation, we can just write compress this with this symbol, that is the del operator. Okay, with the basis vectors ijk are the basis vectors. This reduces the effort of writing and confusion while solving the equations. So that is why they have introduced this del operator. Okay, and now what we have is the gradient. The gradient. So next definition is, next concept is the gradient. What is the meaning of gradient? Gradually decreasing or gradually increasing is called as the gradient. It is called as gradient. Okay, I'll take one example. For example, let us say a metal rod is there. This is the metal rod. This is the metal rod. When I heat this end, so this end is heated. Let us say this end is heated. Okay, this end is heated. What happens? The temperature will be high here. Temperature is high. Let us say this is room temperature. This side is room temperature. So here at this point, the temperature is very, very high. Okay, of a metal. Say red hot. This is red hot. So we have heated it till the red hot. Then at this point, the temperature will be little less. At this point, temperature will be less. So gradually temperature is decreasing in this direction. Okay, what is happening? The temperature is decreasing in this direction. At this point, temperature is room temperature. It is not hot. Okay, it is not hot. That means there is a temperature gradient from this point to this point. Gradually, temperature is decreasing. So this is called as the gradient of temperature. This is called as the gradient of temperature. If the temperature is equal at this point and at this point also, then we say the gradient is zero. Gradient is not at all there. Okay, but what I have told you in this example, the gradient is there. Here there is a hot and here there is a cold. Okay, so there is a temperature gradient, and that can be written as say the temperature gradient T is equal to minus dou by say this is dou T. Okay, dou by dou T of or dou x, because distance I am considering dou by dou x of the temperature. Say this is T. I'll take temperature as T. Okay, and with some unit vector, some unit vectors, that is ax along one direction, some direction. Okay, so this is the temperature gradient. Why this is negative? Negative because it is going in the decreasing direction. The direction is in the decreasing order. So this is the vector. This is the temperature gradient vector. Temperature is not the scalar quantity. Temperature is not vector quantity. Temperature is scalar quantity. When I take temperature, gradient of temperature, that is the vector quantity. Gradient will always have the direction. Okay, in the same way, we can write the potential. We can write the potential. Okay, you have heard of potential difference. Potential difference. What is that potential difference? Actually, it's a voltage. Okay, one point potential will be high, electric potential. Okay, at one point potential will be high, at another point potential will be less. Say this is the, so where do you attach this batteries or here, and from this point and this point you measure the voltage across this. Okay, so across that you're going to measure the voltage across this capacitor or this. There is a voltage difference between 2 points. Okay, that is written in this form. That is the electric potential, can be written as E, right? Electric potential E is equal to, that is minus dou by dou R. What is varying? That is the potential is varying like this, right? Or you can take AX, AR, whatever. This is the vector quantity. As we have taken the temperature as an example, this is the voltage or the potential as an example, where the what this negative sign indicates. This is the potential is in the decreasing. One side the potential is high, voltage is high, and here it is voltage is less. So if there is a potential difference, then only the electrons can flow, then only the current can flow in the circuit. If there is no potential difference, then current will not flow. Okay, so it is like water stored in a tank on the terrace. So if there is a height, so then only the water can flow to the ground floor. Otherwise water will not flow. If the height of the tank and the tap both are at the same potential, then water will not come. So there should be some difference between the tap and the water tank, then only we can get the water in the tap. Otherwise we will not get the same thing. There should be some gradient. This is called as the voltage gradient or the potential gradient. If it is there, then only the current can flow in the circuit. Okay, so this is decreasing thing, and we can write this in the Cartesian coordinate like this. Let us say this is E. Okay, then this can be written as this del operator can be written as like this. That is dou V divided by dou X. Okay, with this AX as a base vector plus dou by dou Y of AY with this uh, with this potential plus dou by dou z of this v with this base vector. So this is how we can write the equation, and this is operated on what? This is operated on the velocity. So that what is this? This is minus, okay, on what we are applying. This is del operator. It is there, okay, operated on v vector v, operated on vector v. So this is the E. Okay, hope you are understanding this. There is no dot over here. You should remember there is no dot over here. So we have not kept any dot there. Okay, this is just del v. That means this is the gradient of the vector v, where vector v is the potential. Okay, potential gradient, and this is called as the gradient. This is called as the gradient. You can write it as del and t. Okay, where t is the temperature gradient.